that means that everything you say comes up on here. So don't say anything dumb. Yep. Camden knows about this. Okay, so we are doing lesson 4.3, and we are going to be talking about parallel and perpendicular lines. Okay, parallel and perpendicular lines. This is one of the things. So, writing equations of lines we use through all our math classes. Parallel and perpendicular lines especially comes up in geometry class, which is what you do next year, a lot. Okay, a lot. Parallel and perpendicular lines. So, here's my question. I know that you know a little bit about parallel lines. Second hour says you do. So if these, what's true about parallel lines? Let's go that way. They never touch, right? So think about in the real world around Fremont, where do you see parallel lines?
Driving places.
Do you want to be more specific?
Roads.
What about roads?
You know, like how there's two white lines on the side of roads, and you never.
That street light.
Okay. So at those, the white lines on either side of the road, those are parallel to each other. They never cross.
Like the yellow line in the middle of the street off there.
When there's two of them, they're parallel. Correct. Real road tracks. There's two parallel tracks.
What about the lines on the notebook paper?
The lines on the notebook paper are parallel. They never cross. Okay. So.
The lines on the U.S. flag.
Correct. Okay. So parallel lines never cross. But my question is to you: do you know why?
Because it's just two lines.
They have to be
Straight.
Because they go on forever.
All true, but it doesn't. I can draw two lines that cross and go on forever.
They go on forever, but never touch.
Thank you. I know that, but why?
Because
I don't
they're
know. Because they're straight. Okay, listen. I can draw. Look, I can draw this line. It's not very straight, but it goes on forever, right?
Yeah.
And I can draw this line that is a straight line and goes on forever, but they cross. So you can't say just that. So the reason is closer. Yeah, you can't say, hey, why are they parallel? Because they're parallel. That is called circular reasoning.
It's like a single line.
Right in front of me.
No, it doesn't have that. Doesn't have that relationship because parallel is by definition two things. Okay, so parallel lines are parallel because they have the same slope. Parallel lines are parallel because they have the same slope. So I want you to think about that. Slope is rise over run. So let's say something has a slope of 3/4 and you have two lines. That means this guy's going to go up 3 and right 4, and they're both going to go up 3 and right 4 always. And so because they're moving the same, up 3, right 4, up 3, right 4, they'll never cross because they're doing the same slope all the time. So parallel lines have the same slope. Now, there's another thing which is already up here, and that's perpendicular lines. Okay, perpendicular lines, I'll give you this one on the diagonal because I can. Okay, they make an X shape, but, whoops, sorry, there you go. Perpendicular lines cross at a 90-degree angle. Okay, so here's my question. Where do you see real life 90 degrees? Four-way stop, right? Four-way stop is usually perpendicular lines. Yeah, anytime you see a square or rectangle, those are perpendicular.
That whiteboard.
What about it?
It's 90 degrees.
Okay, it's got 90-degree corners.
Where the red line crosses the blue line on the notebook paper.
Fair, right? Red lines crosses blue lines right here, 90 degrees. Those are perpendicular lines. So their slopes have a relationship also. Okay, and this is where you need to write this down because this is something you don't know. So perpendicular lines have opposite reciprocal, I will tell you, slopes. Okay, we'll talk about what that is. I want you to write it down and we'll talk about it. Okay, now the words opposite and reciprocal are mathy words. But opposite has a word if you like, or has a meaning. It is a word. Sorry, opposite has a meaning if you're in a different class too, right? Like if you're somewhere else, you can be like, hey, that's the opposite. English class has opposites all the time, right? Like, I don't know. Help me out with some opposites. Light and dark, right? Those are opposites. We know, and it has nothing to do with math class. Day and night. In math class, opposite means that it has the different sign, right? So opposite means change the sign. So opposite means opposite. Nobody's ever going to be like, hey, that's a change sign. You're going to say it's the opposite. Okay? It's the different sign. I want to say opposite. It's the opposite sign. Reciprocal means that you flip a fraction over. Okay, so we'll talk about, I'll show you some examples, but reciprocal means flip the fraction. That looks like one word, sorry, flip the fraction. So if you remember from whatever class Camden's talking about where you did keep, switch, flip the fraction, that's a reciprocal. Okay? Yikes, I don't even know why I said that. Okay. Jeez, I lost my train of thought. Thanks. Wherever KFC came from. Okay, so let's do a couple examples here so that you know what is going on. Okay, so let's say I'm going to give us a slope and then we're going to write the opposite reciprocal. You probably should. Okay, so if the slope is 2/3, his opposite reciprocal changes the sign and flips the fraction. It's going to be negative 3/2. Okay, well, that's fine too, but you want it to be a fraction to do the flipping. So opposite reciprocal, flip the fraction, change the sign. So then let's say we have negative 5/2. Okay. Thank you for stealing everybody's learning moment. Camden, seriously. Okay. This is going to be what? Positive. Change the sign. 2/5. Flip the fraction. Change the sign. Flip the fraction. How about this one? Okay. Do not steal anybody's learning moment, please. Okay, Ethan, what do you think? Huh? Very good. Okay, 4/5 is correct. Okay, how about this one? This one, do not speak out loud. I would like you to try this and then consult with the person sitting next to you, person or people sitting next to or near you, and see if you agree.
I'm wrong. Miss Douglas, she looked at your hair. Miss Douglas thinks
It is definitely positive. Okay.
or vice versa.
What do you think? What do you think is the slope? Lorelai, what do you think? 4. Nope, it's not 4. It's not 4. Braylon, what do you think? 1/4.
That was my second guess.
Okay, so let me ask this question. It's positive because we changed the sign. Nobody has a question about that. Where does that 1 come from? Where's the 1 come from, Bastion?
Every time you have like a number, you would have to do a fraction, you put over 1.
Yes. If it's not a fraction, remember that you put a 1 underneath it to make it a fraction. So that we do that when we're doing slopes, so we can do rise over run, but it pertains here as well.
Do all numbers have like a 1 underneath
Yes.
them, like with X's?
Yep, absolutely. There's always an imaginary 1 under those. Okay. Last one, and then we will let's make this negative. No, let's make it positive. Positive 1/2. Please. Yep. Okay, what do you think? Okay. I heard -2/1, which if you put that on a test, I would take points off. What's that equal to? This it's not. So this is -2. Did I write it as 4/1 when I gave it to you? Because that's not simplified. This is not simplified all the way, right? That's a reducible fraction because 2 divided by 1 is 2. So you have to just take it all the way. That's all I'm saying. Just take it all the way. Okay. Now, let me give you this question here. Let's say we have 2 points. So let's say that we have the point, or sorry, we have 2 sets of points. -1, -2, and 1, 0. And then we're going to call this one A. We're going to call this one B. B is 4, 2, and -2, -2. Okay, I would like to know, are these lines parallel, perpendicular, or neither? Okay, so let me pause a second and help you with a little bit of reasoning. Sorry, that's supposed to be an N. Neither. Parallel, perpendicular, or neither. So if I'm asking you about parallel and perpendicular, what do you have to find if you're going to answer the question?
Slope.
Exactly. So you got 2 slopes to do. Do the slope for A, do the slope for B, and then you'll be able to answer the question. Okay, so give that a shot for me, please. Parallel, perpendicular, or it could be neither. Okay, for letter A, what's the slope?
-1.
Oh, gosh. I think it's +1. I think it's +1. So it's 0, so it'll be 0 minus -2, so that's plus, and 1 minus -1. So they're both plus. So 1/1, which is 1. Okay. What's the slope for the bottom one? +2. Nope. Yep. No. You guys, you're making me second guess. There's so many 2's here, it bothers me. It's positive. Positive, and it's +2. Yeah? Yeah. +2. So parallel, perpendicular, or neither? Neither. Parallel has to be exactly the same. Not just the same sign, but the same exact number. Okay, so let's try another one. Let's do A is 4, 1 and 6, 4. And then B is 1, 3 and 4, 1. Okay, looking for same question: parallel, perpendicular, or neither. The important thing for you to remember when you get asked those questions is you gotta find the slopes. There's no other way to do it.
For parallel, do they always have one? The two have one together?
No.
No. I was wondering if it doesn't make that.
Nope.
That was it.
Yeah, no. It just happens to be the same. Okay. What's the slope of the top? 3 over 2 is correct. So the top slope is 3 over 2. What's the bottom slope? Okay. So are those parallel, perpendicular, or neither? Perpendicular. You can see we switched it and we flipped it and we switched the sign. Okay. One more. Just the last one of these, and then we'll do something similar but not the same. No.
Wait, what are we gonna do?
Just extend what we're talking about. Okay, so there's one, and the other one is -3, -4, and 2, -5. Okay, same question: parallel, perpendicular, or neither?
Oh my.
Find the slopes.
You almost had to do paperwork twice.
I've been done it right this whole time.
Yeah, because
You've just been yapping.
you fell yesterday.
I'll stop
Oh,
talking.
you.
Yeah,
Miss Douglas, did you see that? Miss Douglas, my class.
That's correct.
No.
Don't even to you.
Top 10 rappers.
Did you see that?
What is that from? I don't know. Just do what I'm asking you to do.
Did you see that happen?
No. I just saw you pick yourself up off the floor.
I was on my chair. So my chair,
Ashton, you
my
just
chair was
ruined
like
it.
this, and I went to move my chair. But my pants got caught on my chair, and it moved my chair, and I missed
She almost
my
missed
chair.
How many times did you sit chair during
A lot.
I've never heard someone.
Rest of Michael.
Hey, folks. I need you to bring it back for me, please. What does that mean? What's it saying in your notes?
Parallel.
Hey. What's the slope for A? -1/5. What's the slope for B? So are they parallel, perpendicular, or neither? They're parallel. Okay. Now, same question. This one was perpendicular. Okay, so same question, but we're switching it up a little bit. Let's say this is gonna extend back into things that we talked about last semester. Last semester. Y equals 4x plus 2, and B is x plus 4y equals 3. Okay, so the same question. So I'll write it down. Parallel, perpendicular, or neither? Okay, which I didn't write down. There you go. Parallel, perpendicular, or neither. Okay, so if you are going to answer a question about parallel or perpendicular, you gotta know what the slope is. Okay, the first one, line A, what's the slope?
4.
4. You know that because slope is always the one that has the x. So slope is 4. What's the slope for B?
1.
No.
It's -4.
Okay, so listen. In order to find the slope, you have to have him in slope intercept form. We did this last semester. That means you have to get y by itself. Okay, so that's always true. You cannot tell what the slope is. This is something called standard form, which I'm not worried about if you know that, but you have to get y by itself. So 2 steps. It's always 2 steps. What's the first thing you're going to do? You got to move the x thing first. So minus the x. So we have 4y equals 3 minus x. How many x's is that? 1. Put the 1 on there. That'll make your life easier when we do this. Okay. Now, I get the y by itself, so I move the x thing, and then I do what? Gotta divide by 4. Now, we talked about this in my class. I don't know if you talked about it in your other classes, but you divide all the pieces by 4 because you want it separate. You want the slope and the y-intercept separate. So y equals 3/4 minus 1/4 x. What is the slope of B? Nope. Negative 1/4. Pretty close, but it makes a big difference to answer this question. Are they parallel, perpendicular, or neither? You gonna answer that like a human being or just like a 4-year-old?
I can do like.
Thank you. I so appreciate that. This is perpendicular because these are opposite reciprocals. We actually have this one above with the 4 and the 1/4. Okay, these are perpendicular. Okay, let's do one more like that, and then we will do another one. A different thing. Let's do line A is going to be 3y minus 2x equals 9. And line B is y equals 2/3 x. Isn't it nice that I'm not making you solve 2 of them? Yeah, don't forget that, okay? Okay. Okay, so if you do not have this, I just lost this, sorry. If you do not have the slope given to you, like line A, you have to solve for y. You gotta get the y by itself. Always, 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 always. What do you, if you're going to get that on line A, if you're going to get y by itself, what's the first thing you need to do? Always move the x thing first. So plus 2x in this case because you got to add. Because minus. Plus 2x, plus 2x. So 3y, 9 plus 2x. Now what? Y by 3. Okay, so this guy is y equals 3 plus 2/3 x. Parallel, perpendicular, or neither? Same slope. Now, I'm going to actually tell you it's more than just parallel. But no, we can't have both. Look at those two. It's the same line. Right? Because they have the same y-intercept also. But for this, they will count as parallel. Okay, now.
Wait.
What?
Well, like, wouldn't they be touching the whole time though?
Oh, that's a great point. But I think that because the definition of parallel, like you guys think about parallel, this is not a slam, like you guys think about parallel as they never touch. The definition, the mathematical definition of parallel is that they have the same slope. So I totally know why you're thinking that. It's because they have the same slope that they're parallel. Question? Was there any other questions?
How is there supposed to be two lines if they're on the same line?
Good point. Oh, you know why? Because I wrote it down wrong out of the book. It's supposed to be -9. That might help a little bit. All right. Okay. So here's how you're going to see it. Like you're going to see what we just did on your homework. This is how it's going to show up on a test or quiz. Equation in point slope form. Parallel to y equals -3x plus 4 through the point 1, 9. All right. So on a test or quiz, it's going to look like this. It's going to say, write an equation. This time it says point slope form. That's parallel to some equation, and it gives you a point. Now listen, it seems like a lot, but I want you to stop and think logically with me. If I'm asking for point slope form, I have to have two things. What are they? No. No. Listen. Okay, this is easy. This is not a rocket science question. So if you might be overthinking. If I ask you for point slope form, you need two things. What do you need?
Slope and x1 and y1.
You need a slope and a point. You said y-intercept.
I said slope too.
Okay, but you also said y-intercept. Okay, you need a slope and a point. Look at what you have. You have the point. Okay? You have the point. You just need the slope. But what we have been doing is finding the slope between 2 points. We don't have 2 points. There's got to be another way to get the slope. Okay, so just a second. Let me write this down. Kyler, you awake? Okay, just far, far away. So if I have the point, I don't have another way to get the slope. That's where this comes in. Okay, it's going to be parallel to the line I gave you. What is true about parallel lines? Thank you, they never touch. But what's true about their slopes? I should have asked that question. Their slopes are the same. So, what slope does this line have? -3. The slope is -3. We steal the slope from here and then we ignore it. So steal the slope, and the slope I will use is -3. Now I have enough information. Listen to me carefully. And I'm telling you this a couple times today because it's a mistake people make a lot. We don't ever use this again. We steal his slope and we toss him out. Okay. Now I have a point and a slope, and I can write my equation in point slope form. I'm done. Now it's an easy question because you have the point and you have the slope. So what's our equation then? Y equals? Camden. It's minus because the slope is negative. Okay. That's okay. Just making sure you know. Okay, so let's do another example here. Let's write the equation in point slope form. That is perpendicular to y equals -2/3 x plus 7 through the point -2, 3. Okay, I want you to listen. Point slope form. What two things do I need? Slope and point. It's point. I need point, not just the y-intercept. Slope and point. I have point. I need slope. Okay, so the key word is perpendicular. Whoops, I underlined that and it's frozen. There we go. It's perpendicular. So what is the slope in this equation here? Negative 2 over 3. But if I want the slope that's perpendicular, what slope am I going to use? Yep, positive 3 over 2. Remember, change the sign, flip the fraction. Then we don't use them anymore. Don't use them ever again. Okay, you only ever use that line because you're stealing his slope. Now you have enough information to write him in point slope form. Ethan, you got a problem with the parking lot?
No.
Okay, scoot back in then.
Whoa.
It's been snowing every day.
We live in Michigan! Okay, so what's our equation? Y equals what? 3. X plus 2. I didn't say I didn't like it, but hello. We live in Michigan. It's not like it's a novelty. Why is that plus 2 in there?
Because it's a negative.
What's a negative?
The 2.
Oh, because 2 is actually negative, so x minus a negative 2. All right, now, I don't want you to have to write all this stuff, so we're going to switch to doing this same thing. We're going to do some more examples, but we're going to do them in a table. Okay? Just going to make it easier. You don't have to write as much. So you need about 13 or so lines. It's okay. You don't have to count them. Just draw some. What? No. You need to have the examples written down. Okay. Like all of these. It's going to be like 7 examples. Listen, this is saving you a whole ton of writing in the long run. Okay, there you go. Parallel or perpendicular. And the other one says point slope and slope intercept.
Why do you write so loudly?
I was just going to say the exact same thing. I think it's just all loud with Camden.
Remember that one day he was fixing his hair on the couch? Oh my gosh.
So I'm doing it yesterday too. Okay, so here we go. Let's say our original equation is going to be y equals 1/2 x minus 5. This is why we wrote the table, because we're going to do 6 of these. And either you can write 6 like we wrote, or we can write once and then just write our numbers down. Okay, let's go through the point 2,6. We're going to go parallel. I spelled that wrong. Parallel. And let's put this in point slope. Now, parallel line. What slope are we going to use? Yeah, 1/2 or 0.5, right? Because this slope is 1/2. Parallel lines have the same slope. So the slope is 1/2. Write your equation in point slope form and you're done. So y equals what? X minus 2. Done. So it's this, you guys, the fact that we're using point slope form is really what ties this whole first half of the chapter together. It's all point slope form. You're just using it for different things. We're still writing equations. It's just that now we've added parallel and perpendicular in with it. Okay, let's try this one. Say we've got y equals 2x plus 3 through the point 0.05 perpendicular. I'm going to stop writing perpendicular. I'm going to start abbreviating it. Slope intercept form. You use your brain here. Okay. What is the slope in the equation that I gave you? 2. What slope are we going to use? Negative 1 over 2 because it's perpendicular. So put the 1 under this guy, right? Give him his 1. Flip him and change the sign. So the slope we're using is negative 1/2. Now, this is the part where you have to use your eyeballs, I guess, more than your brain. You're putting your equation in slope intercept form. What's the equation? 5 minus what? No. 1 minus 1/2. Yeah, you gotta flip him. But you guys, why is that the y-intercept? Yeah, because that's what I gave you. So you don't have to put it in point slope form. So you want to watch for that because sometimes I give you that little present and you're going to want to use it. Okay, I want you to write this one down. And at this point, after we write it down, then we will pause and put it away. Okay, so I want this written down so that we have it for tomorrow. Okay, so y equals negative 2/3 x plus 2. Negative 1 and 4 is the coordinate point. We're going to go perpendicular and we're going to put him in slope intercept again. Okay, once that is written down and you're ready to go for tomorrow, you may put your calculator away and get your phone. And then go back to your seat.